And welcome to Uncommand Online Academy. In today's lesson, we want to look at speed, velocity, and acceleration under motion. In our last lesson, we talked about the Newton's law of motion. Of course, I believe you already know what motion is: movement or traveling. So, in motion, speed, velocity, and acceleration are very common terms, and sometimes they look confusing. So our purpose in this lesson is to clarify the differences between speed, velocity, and acceleration. Now let's start with velocity. Let's start with velocity. Velocity is the rate of change or distance covered. The distance covered during a movement over time in a given direction. The distance covered in a movement over time in a given direction. If you are going from north to south, you know the direction of your movement. You are moving from north to south, and you cover a distance of 20 kilometers in 10 seconds. The velocity is the distance covered, which is 20 kilometers over 10 seconds. Now we consider velocity here because we know the direction of our movement, we know the distance covered, and we know the time. When we know the direction of the movement, we talk about velocity. Now, the distance that is covered in a given direction is actually called displacement. So there is a small difference, or we just use another term to show a distance covered in a given direction and distance covered in non-specific direction. So in velocity, we consider what we call displacement. So we say displacement over time. Displacement is still the same thing as distance, but this distance or length, we know the direction of it. So if you are going from north to south, or you are going from south to north, or from north to east, or from east to west, you know the direction of your movement. You move in a straight line towards that direction. We consider it a displacement. Now when you divide the displacement you have by time, you get what we call velocity. Velocity is measured in meter per second. It is measured in meter per second. Now what this means is this, that anytime you want to calculate the velocity, if the distance given to you is in kilometer, you must convert it to meter. And if the time given to you is in hour or minutes, you must convert it to second, because we are considering second, meter per second. If the distance is given to you in centimeter, millimeter, or any other units, you must convert it back to meter for you to use it and calculate your velocity, because the unit of velocity is meter per second. Now, when we know the direction and we know the quantity of something we are considering, we call it a vector quantity. A vector quantity. Like the velocity here, that we know the magnitude. The magnitude means the quantity of it. If you divide the displacement you have by time, you get a number, something, maybe 2, 4, or anything. That is the magnitude or the quantity of it. Now, and we know the direction, maybe from north to south or from south to west. Now, because we have the magnitude and we have the direction, we say that velocity is a vector quantity. Any quantity or anything that you know is magnitude or is quantity, and you also know its direction, we call that in a vector quantity. Velocity is one of it. Now let's see an example of velocity, or how velocity is used or calculated. If a man travels 20 meter north or to north in 5 seconds, calculate his velocity. The man travels 20 meter north in 5 seconds. Now, what is the velocity? Now, I say that velocity is displacement over time. This distance covered to north, because we know the direction that it traveled to north, we call it displacement. So v, which represents our velocity, is equal to 20, which is the displacement over time, 5, which is now 4 meter per second. Now let's look at speed. Speed, on the other hand, is distance covered in a given time. Distance covered in a given time. Now, distance is differentiated from displacement by the fact that in distance, we don't know the direction. So, if a movement is made in non-specific direction, that is, the movement is not in a straight line, then we consider it a distance. So if somebody moves to east and then to south and then maybe to west and then to north, when you take the total of this movement, you combine the total of the movement or the distance covered, we call it distance. You check the length from here, from north to west to east, from east to west, from west. You calculate all the distance covered, the various distances or length covered. We term it a distance. Now, this shows that the movement is not made in any specific direction. The movement is not in a straight line. A straight line means that it is going in either one of the cardinal points to north, to south, to west, to east. That is what I mean by straight line. Just going towards one certain direction. It doesn't mean that if the person moves or have a kind of zigzag movement going toward the same direction, that you will not consider it a displacement. You will. But when the person moves from north to south and then to another direction, we consider it a distance and no longer a displacement. So speed, we represent speed in physics with s. So speed s is equal to distance over time. Distance over, we represent speed you can say speed actually and you can represent it with small letter s or leave it as speed. But what we do is that most of the time we leave it as v, which is still the symbol for velocity. Now we do this because we represent distance with s in motion. We represent distance with s. And so when we are talking about speed and velocity, most of the time we use the same symbol v to represent the speed and velocity, because we also use s to represent both displacement and distance in motion. So you can write it in full speed or you can write v, but this is conventional. Actually, you can use anything you like to represent it, but for uniformity we use v for velocity and speed, and we use s for distance and displacement. So speed is equal to distance over time. Now distance means that the movement is not made in any given direction. Now if we divide distance by time, we will get a quantity, maybe 2, 4, 5 or something. That represents the magnitude of speed. Now, but because the distance is not made in any specific direction, it is not a vector quantity. A quantity or anything that is not a vector quantity is considered a scalar quantity. Scalar quantity. So scalar quantity is a quantity that has magnitude but no direction. So anything that has quantity or that has magnitude but it does not have a specific direction that it goes, that thing is considered a scalar quantity. Example is speed. Example is speed. So we have magnitude, it has it. Direction, it does not have it for scalar quantity. Now the units of speed is the same thing with the unit of velocity. Both of them are measured in meter per second. Meter per second. Now let's look at an example of how we use speed. A man covers 25 meter in a journey. Calculate his speed if he covers the distance in 5 seconds. Now the distance covered is equal to 25. Now the time is 5 seconds. Now that means that the speed is equal to 25 over 5. Now which is equal to 5 meter per second. Now let's go to acceleration. Acceleration talks about how speed or how velocity changes with time. How speed or how velocity changes with time. If someone is traveling or driving a car, and sometimes the person will want to drive faster, and sometimes the person will want to slow down, how this changing of speed or velocity takes place is what we call acceleration. So when you are accelerating, you are changing speed or velocity constantly. You are accelerating means that you are changing speed or your velocity constantly from maybe 1 meter per second to 2 meter per second to 3 meter per second to 4 meter per second. Then you are changing it at different time. Maybe after 5 minutes you change it to 2 meter per second. After another 2 minutes you change it to 3 meter per second, and so on and so forth. So the rate of change of velocity with time or speed with time is what we consider acceleration. So acceleration is equal to acceleration, which we represent with A, is equal to velocity over time. Velocity over time, or speed over time, that is V over T. This is acceleration. Now let's look at an example of how acceleration is used. A car starts from rest and moves with a speed of 100 meters per second. A car starts from rest and attains a speed of 100 meters per second in 10 seconds. Find its acceleration. a car starts from rest and attains a speed of 100 meters per second in 10 seconds, find its acceleration. Now, speed or velocity is equal to 100 meters per second, and time is equal to 10. Now, acceleration is equal to v over t. The unit of acceleration is meter per second squared. Meter per second squared. So this is the answer, 10 meter per second squared. Now let's look at velocity, speed, and acceleration together and understand the concepts, what each of them actually mean when we look at them together. Now let's see that we have a car that is moving. This is the distance covered. Let's say that this place starts from origin, that is at points. The starting point is called the zero or the origin. Then it attains a speed of, or it covers a distance of 100. Let's say that it reaches 100. Now this place, the starting point, this point represents the speed. Let's say 100 at the top. Now, if the car starts from the origin or from the start, when you kick the car, it is not moving. So if the car is not moving, its speed is 0. So anything that is not moving, the velocity or the speed is 0. Now, when the car starts moving, it will change. The velocity will change and distance will change. So the changing of the distance, this place represents distance covered with time. Let's say this one is distance or displacement, and this one is time. Let me consider velocity first. Now, as the distance is changing, this is 100 and this is 100 seconds. At point, let me say this place is 1. This one is time, 1 second. This one 2 seconds. This one 2 seconds. This one 2 meter, 1 meter. It starts from 0. It has not covered any distance. Then it moves to 1. Then it comes to this. Okay, so this at point 2, that is distance equal to 2 meter. It gets there in 2 seconds. So calculating or checking how the distance is related to the time is what we call the speed or the velocity. How the distance or displacement is related to time is what we call speed or velocity. if the car covers much distance in very short time, we say that the speed or the velocity is high. That is, if this same car that covers 2 meters in 2 seconds, if it now covers, in another graph, it covers, let me say, 4 meters, it covers 2 meters in 4 seconds. It means that this one it has higher speed. This one that covers 2 meters in 2 seconds has higher speed than this one that covers 2 meters in 4 seconds. So it takes longer time for this one to cover a distance of 2 meters. This one, with just 2 minutes, in just 2 seconds, it has covered 2 meters. But this one, in 4 seconds, it takes it 4 seconds to cover the same distance. So velocity is talking about the time. Velocity or speed is talking about the time that it takes somebody or something to cover a particular distance. So the higher the time, the higher the distance covered in a specific time, the higher the speed or the velocity. So that is the concept of speed and velocity. Now coming to to acceleration, then we have time and we have velocity. If we have a car again and the car starts from rest, and then in 2 seconds, let me say that the highest velocity attained is 100, and it takes this car, we have 2 cars, let's consider 2 cars. Now this one, it takes this one, let's say that this place is 2, it takes this one 2 seconds to reach 100 meters per second, this velocity. And this one, it takes this one, let's say that this place is 4 or 5 seconds. So it takes this one 5 seconds to reach the same 100 meters per second. Then we see that this one is accelerating faster than this one. What it means is that this one is changing its speed faster than this one. In every 0 point something second, this one will change its speed from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to 100. It doesn't take it time for it to get to the speed of 100 meters per second. But this one, it takes this one much longer time to get to the same speed. So this one, let's say that this one is A and this one is B, car B. So A accelerates faster than B. Now, if you have a velocity time graph, the graph that comes towards this side, that moves towards this side, it has slower or lower acceleration. While the one that goes toward this side, that comes toward the y-axis, that one has higher acceleration. The one that comes towards the x-axis has lower acceleration, while the one that comes towards the y-axis has higher acceleration. So these are just the few things we should know about acceleration, speed, and velocity. That's the concepts of it.